Welcome all, this is Matts Mapping and GIS. In this video I'll provide a demonstration of a concept I've been developing, a Dynamic Geometry Constructor. I also term this as a vector geometry template. This is a methodology that allows for the rapid creation of complex vector elements, dynamically responding to your input. This toolset can instantly generate intricate designs for facilities, infrastructure, land use, and controlled areas, in both 2D and 3D. This has the potential to drastically improve planning development applicable to a vast amount of industry sectors. So what exactly have I created? At its core, the Dynamic Geometry Constructor uses a feature for its datum, this example using a feature line. This designates the left of edge of the runway as the datum. The tool intelligently reads the geometry and attribute information from this line. Based on that input, the tool then performs the creation of numerous associated points, lines, and polygons. This vector information also includes Z values for vertical height, making it powerful for 3D analysis and planning. The real advantage lies in the tool's adaptability. Once generated, this output information can be immediately inspected and measured against your specific requirements. Need to modify the design? No problem. Simply update the required input values and rerun the tool. There you have a new output instantly, perfectly aligned with your revised restrictions and constraints. At this point of the video, I want to explain that I don't have aviation or civil engineering qualifications. The use of terminology and placement of aerodrome elements I'm just using as a demonstration and possible application. If I get something wrong, please provide correction in the comments. I don't want to distribute incorrect information. I'll now briefly explain some of the elements that I've incorporated within this toolset. The edge light is placed with an offset to the left and right edge of the runway. These lights are placed with a customizable separation along the length of the runway. The threshold lights are placed with an offset of the ends of the runway. These feature customizable separation. The Doppler high energy frequency omnidirectional range has a customizable offset from the ends of the runways. These feature both the point and the clearance areas. The precision approach path indicator are placed as a customizable row count, separation and width from the ends of the runway. The exhaust wake's angle, distance, and runway inset are all customizable. Internal and external barriers highlight the distance from the edge of the runway. The center approach can be configured for bearing and distance. The left and right approaches can have their leading edge and widths adjusted. The runway end safety areas can have the offset, length, short edge and long edge customizable. I've also created guidelines for further measurement and planning. This describes the centerline and 15-degree bearings from the runway. I've also allowed recording of input values written to all output features. This tool aims to tackle a major pain point in development planning: the time and effort involved in modifying and adjusting complex and numerous geometries. Without tools like this, redesigning planning proposals can drastically inflate project timelines. Here I adjust the input values and rerun the tool, resulting in a very different geometry output. It's important to clarify this tool won't replace precision surveying. On-site measurements will always be necessary before final planning approval. Its primary goal is to significantly increase productivity and enhance the identification of land use opportunities during early planning phases. Here is a side-by-side comparison of the two outputs. My cursor is moving over the PAPI lines. On the right hand side, I've increased the count but reduced the separation. The exhaust wake is increased in distance and bearing. I've also increased the internal and external barriers. And lastly, the approach bearing and distance has been increased. Even in situations where planning is fluid or established rules for element placement are minimal, our constructor can still generate a minimal viable feature or element. This feature can then be flagged for human review, logic check, and solidification, while reducing the need to build out the vector geometry. Here I'll show a practical example of the input being developed and the tool being run. The line will represent the left-hand edge of the runway, and this will provide the datum for all other elements generated. Consider the scenario for emergency planning and operations. Imagine needing to quickly assess new viable landing zones. There will be a likely need to produce numerous plans over various areas to support a rapidly evolving emergency situation. This tool could be used to eliminate unfeasible zones and communicate technical planning to specialist functions. To streamline this process, I've incorporated preset categories. This means analysts aren't manually inputting dozens of values each time. I've also included the flexibility for custom values, a huge quality of life feature allowing for adaptability in unique environments. Consider another scenario with the task of upgrading or enhancing a mass number of airfields. Maybe there is a new aircraft platform, required safety facility, or military defense measures. This tool can be applied to a massive scale. All runways within a geospatial database could be selected and inputted into this tool. Preliminary planning material for potentially thousands of runways could be immediately generated, providing an actionable view of national level requirements. This concept can be used like modular blueprints. You define a template or skeleton for a specific geometric assembly, and then you can deploy and adapt that assembly across vast areas and combine it with other blueprints to create even larger, more complex installations. The aerodrome constructor is just one example. There are a number of other development planning applications this concept could enhance, such as power infrastructure, communications facilities, space and high atmosphere launch sites, environmental and land use planning, military intelligence and defense planning. I have a huge amount of interest and passion for this concept. I'm eager to explore opportunities and utilize this methodology, creating bespoke and purpose-built processes for your specific needs. The more real-world requirements and practical planning considerations we can capture, the more beneficial and effective this methodology can become. For future development, I would be interested in the following: to read additional input data for restrictions and constraints like other buildings, vertical obstructions, infrastructure, and permit restricted areas. To integrate raster data for higher level calculated analysis and optimized placement, incorporating elements like elevation, environmental factors, climate data, risk assessments, and line of sight analysis. Develop surface area placement capabilities, allowing for the strategic arrangement of multiple elements within the constraints of a given area, maximizing efficient land use. And the implementation of long-term phased or stepped development plans. If you see the potential here and have a challenge this tool could solve, please reach out. I welcome all recommendations and ideas. I'd like to assist in any way I can. This has been Matts Mapping and GIS. Thank you and goodbye.